In the year 79 AD, Mount Vesuvius erupted and buried entire Roman cities under volcanic ash. Buildings collapsed, people died, civilizations vanished. Yet nearly 2,000 years later, Roman harbors, aqueducts, and seawalls still stand, some of them stronger today than when they were built. Here's the shocking part. Modern concrete, the backbone of our cities, often crumbles after just 50 to 100 years. Roman concrete has survived millennia, earthquakes, saltwater, and time itself. And in an age of climate crisis, collapsing infrastructure, and rising carbon emissions, this ancient material may hold an unexpected solution. Concrete is everywhere. Roads, bridges, skyscrapers, dams, and yet modern concrete production is responsible for about 8% of global carbon dioxide emissions. Cement, its key ingredient, requires heating limestone to extreme temperatures, releasing massive amounts of CO2 in the process. The Romans didn't do that. They had no industrial kilns, no electricity, no modern chemistry. Still, their concrete outperformed ours. For decades, this baffled scientists. How could a civilization without modern science create a material that modern engineers still struggle to match? Roman concrete, known as Opus Caementicium, was fundamentally different from what we use today. Instead of Portland cement, the Romans mixed lime with volcanic ash, seawater, and fragments of stone. The key ingredient was the ash. Pliny the Elder, writing in the 1st century AD, described a volcanic sand from the Bay of Naples that, when mixed with lime and water, hardened into a single stone mass. That ash came from the Campi Flegrei volcanic region near modern Naples. The Romans didn't understand the chemistry, but they understood the results. Their concrete didn't just harden, it evolved. For centuries, historians believed Roman concrete survived simply because it was thick and overbuilt. That assumption collapsed in 2014. A research team led by geologist Marie Jackson analyzed samples from Roman seawalls at the ancient harbor of Portus Cosanus, built around 27 BC. Inside the concrete, they discovered rare crystalline minerals that do not exist in modern concrete. These crystals formed because seawater slowly penetrated the structure over centuries and reacted with the volcanic ash. Instead of weakening the concrete, seawater made it stronger. The material healed itself. Cracks didn't spread, they mineralized. Modern concrete fails because the steel inside it corrodes, expands, and tears the structure apart. Roman concrete had no steel and no internal time bomb. Modern concrete behaves like a frozen system. Strong at first, but brittle. Once it cracks, failure begins. Roman concrete behaved more like a living material, slowly adapting to its environment. As water entered, the structure responded by growing new mineral bonds that locked everything tighter together. It didn't fight nature, it worked with it. That difference matters now more than ever. By 2050, humanity is expected to build more infrastructure than in all of previous history combined. More cities, more roads, more coastal defenses. If all of it is built using modern concrete, emissions will continue to rise. Roman-style concrete offers a different path. It requires lower temperatures to produce and replaces carbon-heavy cement with volcanic ash or industrial byproducts. Studies suggest this approach could reduce emissions by up to 85%. It also lasts far longer. Structures that endure for centuries don't need to be rebuilt every few decades. That means less mining, less energy, and less waste. Durability becomes sustainability. And then there's self-healing. Modern researchers have now recreated the Roman process where microcracks seal themselves when exposed to water. This wasn't a new invention. It was a rediscovery. Today, Roman concrete principles are being tested in marine construction, self-healing infrastructure, and low-carbon building materials. In Italy, engineers restoring Roman structures have learned that replacing ancient concrete with modern mixes often weakens the building. The ancient material still wins. Here's the irony. Modern concrete was never designed to last forever. It was designed to be fast, cheap, and scalable. Roman concrete was designed to endure. The Romans built for an empire they believed would last. Modern society builds for short-term efficiency. And now we face crumbling bridges, failing roads, and a warming planet. The Romans didn't save the world, but they left behind a lesson. Progress isn't always about moving forward. Sometimes it's about recovering what we forgot. 2,000 years ago, without climate models or carbon budgets, Roman engineers created a material that worked with nature instead of against it. And beneath the ruins of their empire lies a quiet warning. Civilizations don't fall because they lack technology. They fall when they forget how to build for the future.